All right. Welcome to automating your smart home without the cloud. So this is me, and I have loved the idea of a smart home for years. I've spent a lot of money and a lot of time chasing this dream where I can adjust my living environment to whatever task or activity I'm doing with a minimum of friction and effort. So imagine that you're sitting on the couch on a Sunday afternoon, dog or cat in your lap, and you decide you want to watch a movie. But you're already really comfortable, you don't want to get up. So in this dream world of mine, you'd be able to press a single button or give a single voice command, and the whole environment would shift into a configuration optimized for midday movie watching. So if it's bright outside, your shades would close to block out sunlight, overhead lights would turn off to eliminate glare, side table turns on a little bit, but dim so you can kind of still see to move around. Your cell phone goes into vibrate mode, and through all that, the cat or dog never leaves your lap. Right? That's the kind of smart, automated, frictionless home that I dream about. And when COVID hit, I needed a hobby to stay occupied, so I got rid of all of my old smart home gear, and I wanted to see how close I could get to that smart home nirvana by starting over from scratch with today's technology. And despite all that technology that's available these days, doing anything really interesting is still very difficult. Because we spent $65 billion on smart devices in 2020, and for most people, the pinnacle of their smart home experience is still having a few light bulbs they can turn on or off with their phone as long as the internet connection is up and as long as no one turned off the power at the wall switch. I think that's dumb. But the smart home industry is still very early in its growth, and the mainstream tech is still optimized for very basic use cases. You can do more interesting things, but it requires a little bit of technical skill, a little bit of knowledge, and a little bit of elbow grease. And that brings us to today. This session is a summary of everything I've learned and implemented in the last 18 months. I'm going to show you what's possible with today's tech, and I'm going to give you a roadmap of things that you can research on your own as you begin your own smart home journey. We're going to talk about why you should care about local control and execution, the different types of devices and protocols and how to choose between them. I'll introduce this thing called Home Assistant and how to get started with it. I'll share some really cool things I'm doing in Home Assistant to make my home smarter, and I'll show you how you can use cloud services without being dependent on them. So to start, I think it's really important to talk about why you should care about automating your home without the cloud. I mean, it is super easy and convenient to buy a light bulb, connect it to Google, and walk around saying, "Let there be light," and having your house lights turn on. But if you take the easy way out, right, you're accepting some serious drawbacks, and limitations that, in my opinion, are deal breakers. So I think it's dumb for your smart home to lose functionality just because the internet connection is down or because someone's having an outage out there on the internet. In 2018, a company that produces smart thermostats had an outage. And the thermostats not only lost their smart functionality, like scheduling or remote access, they stopped functioning as basic thermostats, leaving people unable to heat their homes. In another example, an AWS outage took down the Ring doorbell system. Some people had integrated the Ring app with their smart door locks and were unable to get into their homes because the app was down. And it happens to Google too. Google owns the Nest ecosystem. In 2019, a Google Web Services outage took Nest thermostats offline, right? Neat. Granted, those examples are from a year or three ago, and the major players are getting a little bit better about maintaining basic functionality when offline, but it's not just a question of outages, right? Vendors get purchased or go out of business. They shut down services that aren't profitable, and they start charging for stuff that used to be free. Breaking your dependence on cloud services means that those sorts of things won't break your smart home. Second reason I'm anti-cloud is security. IoT devices are notorious for having poor or non-existent security. In one example, a bug in the Ring doorbell system was leaking Wi-Fi login information, which not only compromised your Ring devices, but also could have been used to compromise your entire Wi-Fi network. Cloud services require you to log into them. They collect data about you, and that information can be stolen. So there's no shortage of stories like these, and it's not clear to me that things are getting any better. So the more stuff you run locally, the fewer vulnerabilities you'll have. Cloud services tend to be optimized for very basic use cases. Running your system locally makes it much easier to integrate different types of sensors and devices and gives you more control over how things are automated. And we'll talk about this a lot in a bit. And lastly, I'm anti-cloud because the user experience sucks. One of the first things I tried on this journey of mine was the SmartThings platform from Samsung, and it was entirely cloud-based. So I had set up this movie time automation that would dim the lights in the kitchen and living room to eliminate glare on the TV. My wife and I are getting ready to watch a movie on Friday night, and I want to show off. So she's reaching for the lights, and I'm like, yo, check this out. Alexa, it's movie time. But I got the syntax wrong because Alexa responds with, I don't know what you mean. So I'm like, Alexa, start the movie time scene? But there's some sort of delay between my network and AWS and SmartThings, so nothing happens immediately. I'm just kind of standing there looking like it's going to happen. So my wife rolls her eyes, reaches out, and hits the switch by hand, just turns the light off. So we sit down on the couch, and a second later, I get a notification on my phone from SmartThings saying, hey, I can't reach your light. So by turning off the power at the wall switch, she killed the power to the bulb, knocked it off the network, and it was unavailable by the time SmartThings finally got around to processing the event. So a slight delay may not seem like a big deal, but you might be surprised at how accustomed we are to instant feedback. One of the smart switches that I put in supports scene controls. So if you tap the switch once, it'll turn a light on or off, but you can tap it twice to send additional commands. So when you tap the switch the first time, it waits for 300 milliseconds to see if you're going to double tap or not. So I put these in. I think they're great. My wife complains about how laggy they are. She'd been conditioned by 40 years of modern living to expect instantaneous results when working a light switch. And even that 300 millisecond delay was enough to make things just feel off to her. So if every single thing in your smart home has to round trip through the internet, you or your spouse, your guests, your kids, or whatever may not notice it all the time, but you'll notice it every once in a while, and for some people, it's going to be really, really annoying. All right, so enough of my soapbox ranting. The point is, running your system locally avoids a ton of problems and makes it easier to get to that smart home nirvana that I'm dreaming about. And speaking of that smart home nirvana, let's take just a minute to identify what a truly smart home looks like, at least to me, because these are the things that local control and execution will help us achieve. First, I think automation is better than control. So as an example, consider the laundry room in the basement of my house. To get to the laundry room, I have to open the basement door, go down, turn a corner, go through the workout room, and into the laundry room. There are 5 different lights in 3 distinct areas along that path. Now, controlling the lights with my phone would be neat, but it's not helpful if my hands are full of laundry. And using my voice would be better, but turning on 5 different lights, one by name, gets really old really quick. I could group the lights into a scene and use my voice to control the scene, and that's not terrible, but it only works if the smart speaker can hear me. I have to remember to turn off the scene when I'm done, and it requires training my wife and my kids how to use that same scene. And really, I don't want to just control the lights. I want them to be automated. So I put in motion sensors in each of those 3 distinct areas. As I open the basement door and go downstairs, the lights turn on automatically as I enter each area. They stay on while I'm there, then when I leave and no motion detected, they turn off automatically. Sounds really basic, but it's a huge quality of life improvement. My brother stayed with me for a week at Christmas, and at first he's all like, you're too lazy to work a light switch? But after just a few days of staying there and actually doing this and using it, he was like, yeah, I kind of see that's pretty cool. But motion-controlled lights aren't new, right? They've been around forever. But in most cases, motion-controlled lights are an example of a dumb automation. It lacks context, and that lack of context really undercuts its value. So for example, after I automated my laundry lights, I decided to add motion-based lighting to my living room too. I seem to be the only person in my house that knows how to turn off a light when they leave a room, and I thought the automations would be a good way to reduce wasted energy. But then my daughter complains that if she's on the couch watching TV and she's sitting still, the motion sensor thinks she's gone and it'll turn the lights off. And she has to like wave her arms in the air every 10 minutes to turn them back on. Now, by itself, that's not super compelling to me. I think making kids move their bodies every 10 minutes to watch TV, that's a feature, not a bug. But I'm really picky about my own TV watching experience. And we sit down one night for a family movie, and I get all the lights dimmed for that perfect theatrical experience. And then the moment someone reaches forward to get popcorn, the motion sensors shoot the lights back up to full brightness, and it ruins everything. And it's one thing to disrupt my daughter's TV time, but I draw the line at things screwing with my movie night. And the problem is that dumb automations don't understand the nuance of our lives, right? So sometimes they're a great help, other times they just get in the way. So I'm far more interested in smart automations that are context aware. I want the lights to stay on when we're watching TV during the day, even if there's no motion. And I want lights to stay off if we're watching a movie at night, even if there is motion. And if we're not watching TV, I want lights to turn on or off automatically based on those motion sensors. And we'll talk more about this in a little bit. Third, I don't care what happens to my internet connection or to anyone else's computer anywhere else on the internet. If I have electricity, I want my lights to turn on automatically when I do laundry and turn off when I leave. And lastly, I share my home with other people, and not everyone is as enthusiastic about this as I am. So my wife is happy to benefit from the automations I've put in, but she draws the line at needing to pull out her phone to turn off a light or disable an overly aggressive automation. So my last rule is that other people shouldn't need a training manual to feel at home. Things should just work the way they're used to, and the automation should be more or less invisible. That's my vision of a truly smart home, and running everything locally, not in the cloud, makes it easier to achieve. So how do we get there? Well, let's talk about hubs. So at the center of all smart homes is some kind of brain. It monitors for events, and then it manages devices in response to the events. So when you do something, you open a door, hit a switch, whatever, that brain responds by sending commands out to your devices. If that brain lives in the cloud, like when you use Alexa to manage your devices, you have all those problems we just talked about. Lots of things can prevent the hub from knowing about the events or prevent the hub from talking to your devices. And even when things are connected properly, you have to deal with the network latency between your house and those services. But if you run that brain on your local network, there are far fewer things that can disrupt its connections, and you get much faster response times as well. We're going to talk about a few of different ways to run that brain on your local network in a minute. But first, we need to talk about protocols, because the way that your devices communicate with each other is a key part of the whole equation. There are 4 different protocols that you should be aware of: Zigbee, Z-Wave, Matter, and our old buddy Wi-Fi. Now, unfortunately, our old buddy Wi-Fi is not a great choice for a smart, locally controlled smart home. The first reason is that there's no standard that specifies how local control should work on a Wi-Fi device. So some devices, like some smart bulbs, expose a local API that can be used to perform basic operations, like turning it on or turning it off. But those APIs are rarely documented, and typically those APIs are designed to support the vendor's app. The vendor doesn't really want a third-party integration calling those APIs. From the vendor's perspective, the need for that device-specific app is the whole point. They want you to use their app because they want you to register your information with them. They want to collect data on you. They want to monetize your engagement with that device however they can. So this lack of standardization makes it difficult to integrate different brands or types of Wi-Fi devices together. And those vendor-specific apps are often poorly implemented, rely on cloud services, and often kind of suck. Wi-Fi devices can also reach out to the internet. That makes them potential vulnerabilities. That device might be sending your Wi-Fi credentials to China. It might be creating a tunnel that allows malicious users onto your network where they can compromise other devices. And even if firmware patches are released, they often go unapplied. Because most people, once they get a smart device working, they tend to forget about it. I mean, when was the last time you checked your own smart light bulbs for a security patch, right? It doesn't happen. So any device that's able to reach out to the internet is a potential vulnerability. So the fewer you have, the better. Now, I'm not saying you can't use Wi-Fi devices. I have some in my own house. There's some things you can't automate any other way. My point is that there are better choices for a locally controlled smart home, and you should know about those. So excluding Wi-Fi, there are 3 viable protocols that you should know about. 2 of these, Zigbee and Z-Wave, have been around for a long time. They're very widely supported. The third, Matter, is a brand new thing that's coming later this year. Let's look at the 2 established ones first. If you go out to the store today to buy a smart bulb or a smart switch and you avoid Wi-Fi, it's most likely going to use one of these 2 protocols to communicate. Both of these are mesh networks that require a hub, and the devices communicate with the hub and with each other. So the more devices you have, the more robust that mesh becomes. On paper, Zigbee has some advantages because it theoretically supports a much larger and more spread out network, while Z-Wave has some constraints that may seem limiting. But in a normal residential setup, these differences aren't likely to matter. You could put a Z-Wave bulb, switch, plug, and motion sensor in every room of your house, and you're not going to hit that 232 device limit. Your wallet is going to run out well before that limit does, and that is the voice of experience talking. In practical terms, though, Z-Wave has a bit of an advantage. Zigbee uses the 2.4 gigahertz spectrum, which is the same as Wi-Fi. It's very fast, but if you have a very busy Zigbee network, those signals can sometimes interfere with Wi-Fi and vice versa. Z-Wave operates at a different spectrum. It both gives it a larger range and avoids interference with your Wi-Fi network. But I think the most compelling reason to pick one over the other is that Z-Wave devices have fewer interoperability and compatibility issues than Zigbee. That's because devices can be Zigbee certified based only on their hardware, even if the software doesn't comply yet. So some devices with the Zigbee logo on the box may not implement the full spec and all of its features yet, and that can cause problems when you're trying to get these things to interoperate. On the other hand, the only way to put the Z-Wave sticker on the box is for hardware and software to pass rigorous testing by the Z-Wave Alliance. So as a result, Z-Wave devices tend to be a little bit more interoperable. Now, I've tried both, and at this point, I'm a very satisfied Z-Wave user. You can build a smart home around either or both, but at the end of the day, I want things to just work, and I had fewer headaches with my Z-Wave devices. Let's talk about Matter. Matter is a new standard that's scheduled for release later this year. It's already been delayed a few times, so it might get delayed again. Matter's whole purpose, its primary objective, is to reduce fragmentation and improve interoperability between Internet of Things devices. Now, the cynic in me can't help but think of this XKCD comic, right? And the possibility that Matter becomes just one more part of the fragmentation, not the one protocol to rule them all. But the consumer in me is really hopeful. I really hope it delivers on its promise, and at this point, all of the industry players are signed on, so it certainly seems to have momentum in the right direction. In technical terms, Matter utilizes both Wi-Fi, Thread, and Bluetooth Low Energy for different purposes. It supports Wi-Fi for high bandwidth devices like cameras, and it uses Thread for low power or low bandwidth devices on a mesh network. Thread is a new protocol designed by Google specifically for home automation. It's sort of like an alternative to Zigbee or Z-Wave. Matter can also use Bluetooth Low Energy to simplify some setup and provisioning of devices. Now, Matter is going to operate at the same 2.4 gigahertz spectrum as Zigbee, so some existing Zigbee devices may be upgradable, and that might factor into your decision to buy things today. It's going to vary from device to device, though, and the details remain to be seen. Despite its lofty ambitions, though, Matter is not going to replace Z-Wave anytime soon. For the time being, Z-Wave is still my first choice. Let's go back to the discussion about hubs. So when I first started my research, these are the 5 hubs and platforms that kept turning up the most. I tried SmartThings first before I knew better. It's very cloud-centric, though that does not work for me, so that was out. And I don't have much experience with HomeKit because it's very Apple-centric, and I am a PC and Android kind of guy. If you treat Siri like a member of the family, then this might be worth your time to look into. It does support local execution, but I wanted something less vendor-specific and more flexible. So that left these 3. I tried Hubitat first because it's an integrated hardware-software system that supports both Z-Wave and Zigbee out of the box. So I already had some Zigbee bulbs. I was learning about Z-Wave. I liked the idea of using them together. Unfortunately, it just never appealed to me. It felt kludgy to use. It didn't have a super active community. Device support seemed a little lacking. So it was inexpensive. It got me started, and I still use it for a few remaining Zigbee bulbs in my house. I'm just not putting any more effort into it. I looked into HomeSeer next, which is another commercial hardware-software package. It's been around for a long time, very well supported, has some very powerful features. However, it's kind of expensive. The hardware-software package can cost up to $1,000, depending on which hub and which features you get, and that's a lot. You can also buy just the software, and you can run it on like a Linux or Windows desktop, but even that can cost up to $150 if you get all the features. And at this point, I'd already spent a bunch of money on devices. My bank account was starting to give me the evil eye. I didn't want to spend a bunch of money on a commercial offering. So I started looking into open source options. And that brought me to Home Assistant. Unlike the others, Home Assistant is a free open source software package only. There's no hardware that you're required to buy. You can run it on all kinds of hardware you may already have laying around the house. It's very powerful and configurable, and it gets easier to use with each monthly release. The main drawbacks are that it requires an external radio or USB device if you want to use Zigbee or Z-Wave, and it's open source. And open source is a double-edged sword, right? There's no customer service department to call if things go sideways, and sometimes it takes a little bit of yak shaving to get things set up. But all in all, I've been really impressed with it. I think it's a great option, especially for tech-savvy people like all of you. So the rest of this talk is going to focus specifically on Home Assistant. I'm going to show you some of the hardware platforms it supports, some things you need to know to get it set up. I'll show you how to manage Z-Wave, Wi-Fi, and some of your existing legacy appliances all in a single dashboard. Finally, I'll show you how to use those devices to create the smart automations I keep talking about. And one of the highlights here will be adding push notifications to my non-Wi-Fi enabled washing machine. So the first step in getting it set up is deciding what you want to run it on. And you have quite a few options from single board computers like Raspberry Pi up to different types of NAS platforms. Now with the current chip shortage, finding Raspberry Pis at a good price is kind of difficult. You can also download virtual machine images that you can run on a desktop on Windows, Mac, or Linux. Does not require a lot of resources. I run mine on a Raspberry Pi 3B, and it works great. Things do get a little bit confusing when you go to install because you can install it in one of 4 different ways. The simplest way is to download the Home Assistant operating system and then to flash it on a Raspberry Pi or run it in a virtual machine on a desktop. It's super easy to do. You get the full experience. The main drawback is that this is a legit operating system. So you can't just install it on an existing device without replacing the existing operating system. If you want to add it to an existing device, and that device can run Docker, you can install Home Assistant as a Docker container. And the main drawback here is that you lose access to the supervisor tools. That means that you'll need to manually update Home Assistant through Docker instead of using the built-in upgrade tools in Home Assistant. You'll also lose access to the built-in add-on store, but most of those things can be installed as Docker containers anyway. So you don't really lose much functionality. You just have to do more of the management by hand. If you have a system running Python, you can also install it into a Python virtual environment. same limitations as the Docker approach. There is a way to install it onto an existing operating system without using Docker and without giving up the supervisor tools, but it requires that you manually install and manage a bunch of dependencies, so it's not recommended for beginners. So if you're just starting out, the simplest thing is to get the full Home Assistant operating system on a Raspberry Pi or in a VM, be up and running in like 15 minutes, and it's really, really easy to keep updated. Now, no matter how you install it, once it's installed, you're going to have to add devices to it. And we're going to spend a few minutes talking about devices because once you have a local hub set up, there are all kinds of cool things that you can do. First up, however, Home Assistant is just a piece of software. It's not a hardware-software package. So if you want to use it with Zigbee or Z-Wave devices, you'll need to add a USB stick with the appropriate radio. This is the one that I use. These things cost like 35 or 50 bucks, and they're basically plug and play. Once you plug it into your Home Assistant device, adding that Z-Wave network to Home Assistant is super easy. There's a Z-Wave JS plugin that interfaces with the USB stick and gives you a very feature-rich device manager directly in Home Assistant. And that device manager is a good example of the benefit of using Z-Wave or Zigbee instead of Wi-Fi. Since Wi-Fi devices don't implement any specific standard, there's no robust way to manage them in a centralized location. But Z-Wave provides a ton of information about your devices. You can configure them, view them, etc., all without any kind of vendor-specific interface. Z-Wave and Zigbee also support low-power devices that can run on batteries. So Wi-Fi devices require a lot of juice. So it's rare to find Wi-Fi devices that run on batteries, and the ones that you do find are going to be larger than their Zigbee or Z-Wave counterparts because they require larger batteries. So one of the benefits of a centralized hub like this is that you can manage all kinds of devices, different types of devices, all in a centralized dashboard. So in my pantry, I replaced the light switch on the wall with a Z-Wave enabled on-off switch, and it controls a standard dumb light bulb. Just an on-off switch, so I can't do much besides turn it on or off, but Home Assistant does keep track of when the status last changed. That can be occasionally useful. In my basement, I replaced the wall switch with a Z-Wave enabled dimmer. And that's connected to another standard legacy dumb light bulb. Now this is a dimmer switch, so in Home Assistant, I can both control the power and the dimming level. Then in my living room, I have a Z-Wave bulb running off a standard dumb wall switch. It's an RGB bulb, so I can control the color temperature as well as on, off, and dimming. Now, all these things are being controlled locally through Z-Wave. There's zero dependency on any external processor, protocol, API, or service. You can control some Wi-Fi devices too, if there's a Home Assistant integration for them. In my nightstand, I have a LifeX bulb that uses Wi-Fi. However, some member of the Home Assistant community reverse engineered their local API and published an integration that knows how to use that local API to manage the bulb. That integration gives me the same interface as my Z-Wave RGB bulb. So as a user, I can't really tell a difference. But there is a difference, of course. The Z-Wave bulb is implementing a published standard, locally controlled. The Wi-Fi device integration will either rely on unpublished or undocumented APIs, or it could just be a proxy in front of the vendor's client API or cloud API. So you're not totally SOL when it comes to controlling Wi-Fi devices in Home Assistant. It's just not as easy as Zigbee or Z-Wave. And you don't always get local control. Since we're talking about bulbs and switches, I do have a lesson learned to share. Smart bulbs are really easy to put in, but they have one major drawback, because the bulb must stay powered on at all times. When you hit the off button in the app, it just turns off the LEDs. The bulb stays powered so they can receive connection or the signals to turn back on. But if you put the bulb in a lamp that's controlled by a wall switch, and if someone comes along and turns off that switch by hand, no amount of yelling at Alexa will turn that light bulb back on until you turn the power back on at the switch. But if you put in a Z-Wave wall switch, this is a non-issue. Your kids or spouse or your guests can keep using things manually, like cave people if they want to, without ever affecting your ability to run things remotely through a dashboard. And replacing a light switch it's an easy, safe DIY project. Everyone in this room can do it. You can save yourself a bunch of money in electrician fees by figuring it out. It's well worth learning. And Z-Wave supports more than just lights. I have a Z-Wave thermostat, which was super easy to install. I have relay switches controlling some of my ceiling light fans. You can get Z-Wave smart locks, automated blinds. You can even get a Z-Wave controlled water valve that can automatically turn off your water if there's a leak detected. So lots and lots of options. In addition to all those things I can control, I also have a bunch of read-only sensors that feed into Home Assistant. So I can track which rooms are occupied, the temperature in different parts of the house, how much salt is in my water softener, even whether my garage door is open or not. Now in a minute, I'll show you how you can use those sensor values to create some really cool smart automations. But first I want to show you how easy it is to collect this kind of information in the first place. So motion and temperature sensing is brain dead easy. You can buy battery-powered sensors that have temperature, humidity, and motion sensing built in for 15 to 30 bucks. They stick to the walls with adhesive, and the batteries can last for months. I also use sensors to track the status of some of my appliances, like my washing machine. So a Wi-Fi enabled washing machine would be expensive, and often requires a dedicated app that probably sucks. I don't really need the ability to start my laundry machine remotely. I mean, I have to be next to it to put clothes in it anyway, and it already has a delay start option. But it is very helpful to know when the load is done washing. So instead of buying a new washer, I bought this Z-Wave power plug that has power monitoring built in. So it exposes the amount of power being drawn as a Z-Wave entity. I can easily tell whether the washer is in use by checking that value. And I'll show you in a minute how you can use that to send automations or notifications to yourself. My garage door is another dumb appliance that I monitor in Home Assistant. Now, instead of using an off-the-wall or off-the-shelf Z-Wave sensor, I use a $5 distance sensor coupled with a $10 Raspberry Pi Zero. I have that motion sensor on the ceiling of the garage pointing downwards. So when the garage door is open, the sensor reads the distance to the rolled up garage door, about 18 inches. I map that to a status of open in Home Assistant. But when the garage door is closed, the sensor reads the distance all the way down to the floor, which is about 10 feet. I might map that to a closed state. The status of the door is not only visible in the dashboard, but I can also use it in my automations. Now, I don't have the ability to remotely change the garage door state, but I wouldn't want to do that anyway for safety reasons. So Home Assistant can natively integrate with Z-Wave devices. But if you start setting up DIY sensors on a Raspberry Pi or an Arduino, you'll need to take an extra step to get that data into your dashboard. The technology I use to do that is called MQTT. It's a lightweight, publish-subscribe network protocol, runs on TCP/IP. It was designed to support messages between devices with limited bandwidth, so it makes it ideal for collecting sensor data. It's also very easy to run this locally. Home Assistant speaks MQTT natively, but it needs to connect to a broker that manages the queue. One such broker is called Mosquito. It's a popular open source MQTT broker that's produced by the Eclipse Foundation. It has an official Home Assistant integration that you can install directly within Home Assistant, and it's also really easy to run as a Docker container on your local network. Once the broker is set up, it only requires a few lines of YAML to expose different message topics as sensors in Home Assistant. So my garage door sensor is linked to a specific topic in MQTT. Home Assistant automatically tracks that topic and publishes the most recent message value into the dashboard. It just takes a few lines of Python on the Pi to read the sensor and then push a new MQTT message onto the queue. Very easy to do. And the message itself is just a JSON string. There's no specific schema that you need to implement. It is super simple and lightweight. I do want to emphasize you don't need to buy a bunch of sensors and a soldering iron to run a useful, locally controlled smart home. There are off-the-shelf devices and sensors for everything you'd want to do. But it's kind of fun to roll your own solutions sometimes. I didn't know anything about Python or sensors or Raspberry Pi 18 months ago, and I was surprised at how quickly I was able to pick up the basics. In the meantime, I've not only had fun, I've saved myself a bit of money in the process. So that brings us to this final part where we'll pull together all of those pieces into a truly useful smart home. So I said earlier that automation beats control, and Home Assistant supports automations as a first-class feature. So as an example, let's go back to my living room and the desire for the motion sensor to only activate if we're not watching TV. So basically, if the TV is on, we want Home Assistant to assume the room is in use by a human that put the lights where they want them, and it should leave the lights alone. If the TV is not on, we want the motion sensors to be in charge. Let's see how we can implement that. When you configure an automation in Home Assistant, you got to configure three things. The first are the triggers, which are the things that cause the automation to start processing. And in this case, in my living room, the automation is triggered after 10 minutes of no motion being detected. There are all kinds of triggers that you can use. Device triggers are really easy to read the state of a device. You can also do geolocation triggers so that things can happen when you come home or when you leave. You can also get fancy and create templates with all kinds of custom logic, return some value, and you can have it trigger whenever that template resolves to that value. Secondly, you specify the conditions that must be met in order for the automation to continue processing once it was triggered. This is an example of why running things locally is so nice. So my living room TV uses a Roku as the streaming device. Home Assistant automatically detected it on the local network and installed an integration for it. Super easy. And that integration exposes the name of the app currently executing on the Roku. So if we're watching Netflix, this will say Netflix. But when the Roku is on its just default home screen, the name of the app is just Roku. And the Roku will eventually time out, no activity, and go back to the home screen, even if someone left it on pause for a long time. So checking for that status is a reasonable way to determine if the Roku is being actively used or not. So by making my automation conditional on this value, I ensure the motion sensors only activate if we're not watching TV. You could also use one of those power sensing plugs like I showed you for my washing machine. You can add multiple conditions on an automation. You can make them conditional on all kinds of things. Most of my motion-based triggers only run at certain times of the day. There's no reason for my cats to run around at 2 o'clock in the morning and turn the lights on. Finally, the actions are, shocker, the things that happen in response to a trigger. And they're only performed if the conditions are met. It's really easy to use device actions to change the state of devices, like turning my living room lamp off. But Home Assistant supports a ton of different action types. You can change device states and properties. You can send push notifications to your phone. You can interact with cameras, APIs, external services. You can play media on a smart speaker, et cetera, et cetera. If you can think of it, it is probably in this list. But what if you don't have a Roku or a smart TV, but you still want to make your motion-based automations at least somewhat smart? Well, Home Assistant lets you create these helpers, such as a Boolean toggle. It's just a true-false value or state that can be controlled from your dashboard and can be referenced in your automations. So I have this movie mode toggle, and when it's enabled, it means we're watching TV, we don't want the lights to change. All the motion-based automations in the living room are conditional on that value being off. In fact, I use that kind of override in lots of my automations. It's really, really helpful to have a kill switch for some case where your automation is getting in your way. As an example, some of my light switches, my wall switches, support double tap. So if you double tap up or down, it'll turn the light on or off and then disable motion-based automations for 2 hours or so. That's really useful in our garage because the motion sensors in the garage can't see all the nooks and corners that we're in. So, and it really sucks to go out into the garage, you know, and you're in some corner and the lights just shut off on you and it's pitch black. So when we go out to the garage, we just double tap the switch, turn the lights on, and it just automatically means stay on for the next 2 hours. Another benefit of running a local hub is that your automations can involve devices that are not visible to the public internet. So in my garage, we have lots of expensive tools. I have a camera out there to capture video in case of theft. I don't want a thief to steal the video evidence along with the tools, so that video is pushed onto an external hard drive inside the house that's not stored directly on the camera. But I don't need video evidence every time someone goes out to get a soda from the outdoor fridge. So I configure the automation to only save a video if motion is detected while the garage door is open. If motion is detected but the door is closed, I don't bother with a recording. That setup involves a camera, 2 different types of sensors, and a USB hard drive attached to a local file server. Getting all that to work over the cloud would have been a nightmare. It was super easy to do running it locally. You can also have more control over notifications when you send them yourself. So I have automations that check the power of my washer and dryer. Whenever that value drops from a non-zero value to 0, I know the machine was in use and is stopped, so I send myself a push notification to my cell phone using a service built into Home Assistant. Now, technically, I think this does go out to Google to send the actual notification, but that's the only part of cloud dependence built into that chain. Let's say you have a busy home, lots of people doing laundry, and a push notification to a phone doesn't work for you. You could change a light. You could flash a light bulb a different color. You could play a sound. You could do whatever you want. There's no need to spend a bunch of money on an expensive smart appliance when a simple plug in an hour or 2 on a Sunday morning gives you better results. All right, so we've talked about how to configure devices and sensors, all without cloud services. To wrap up, I want to cover a few more advanced features in Home Assistant that let you do some really cool things. So a few minutes ago, I showed you that movie mode toggle that we can use to disable motion-based lighting when we're watching TV. That toggle can be switched by the dashboard on my phone, but that's not very useful to my kids or my guests. So what I really want is some kind of tactile, analog way to toggle this setting without using an app. I found this really neat device from a company called Flick.io. It's a little battery-powered button the size of a quarter. It has an adhesive backing, so you can stick them anywhere. I stuck one right on the coffee table, right by where everyone watches TV, so it's really easy to spot. Pressing that button turns on that movie mode toggle. So you want to watch TV, you sit down, hit the button, and the lights will stay where you have them. And it was really easy to set up. The Flick app lets you configure handlers for a single press, double press, and a press and hold. One of the actions you can take in response is to perform an HTTP request. Well, Home Assistant exposes this endpoint that lets you pass in any string you want as a webhook ID. The Flick device is running locally, so it can connect directly to my Home Assistant by its IP address on the private network. In Home Assistant, you can configure a webhook automation that will trigger whenever that specific string is passed to the endpoint. And of course, you can do whatever you want in response to that trigger. You can change that movie mode toggle. Our button actually does a couple different things. So we press it, it sets some lights to like a dimmed level for watching TV, and it turns on that movie mode flag to disable the motion-based automation. When we're done watching TV, we can double tap the button. It will call a different webhook, turns the lights back up to full brightness, and re-enables the motion triggers. These buttons are a really neat way to add physical triggers for your automations all over your house. They're in my kids' room, so they can turn on and off their closet lights and ceiling fan lights. We have them in our master bedroom for turning off lights that are hard to reach from the bed. I have them in my office to turn on different parts of my office lighting. They're just really, really cool devices. I love them. I could spend the rest of the session just talking about the real-time event handlers I have in my home, but that's really only part of the value proposition of running your smart home locally. A smart home can also help you spot trends or track data over time. And there are tons of ways of doing this. I'm going to show you two things that I use called InfluxDB and Grafana. So InfluxDB is an open source database that is specifically designed to store time series data like sensor measurements. Like everything else that I'm doing, it can be installed directly in Home Assistant or as a Docker container. Grafana is an open source tool for creating graphs and dashboards. It's very well suited for displaying the data from InfluxDB and can also be installed directly in Home Assistant or in Docker. So here's an example of my Grafana dashboard. And I spent zero time making it look pretty. It is very customizable if you don't love the black and green aesthetic that I'm rocking. So Home Assistant can be easily configured to push data into InfluxDB to track it over time, and Grafana supports InfluxDB as a native data source. So in this example here, I'm tracking air quality measurements. My son was sneezing a lot last summer, and I was trying to figure out if it was allergies or some other air quality issue, and I wanted to measure the impact of our windows being open or closed. So all I had to do was create an MQTT sensor in Home Assistant and configure Home Assistant to talk to Influx. Every time a new measurement comes in, it gets pushed into Influx. Influx stores it over time. I can easily graph it in Grafana. And there are all kinds of things that you might want to graph over time. I was having network connectivity issues for a little while, so I installed a network and ping test plugin in Home Assistant. Every hour, it does a ping test and records that data in Influx. I can then track it in Grafana, and I can see if I'm getting the uptime and speed that I'm paying for. And you're not limited to line graphs either. I barely scratched the surface of the visualizations that you can do in Grafana. So if you're into graphs and charts and data, then it's definitely worth looking into because you can do some really cool things. All right, so we talked about all kinds of cool things you can do with a local setup. But what about remote access? Because no matter how awesomely automated your home is, sooner or later, you're going to have to leave that house and go out into the world. So let's say that you leave in a hurry for vacation. You get a few miles down the road, and you have that sinking feeling that you left a light on or the garage door open or whatever else. If you're running everything locally, you can't just connect to Home Assistant unless you're on the same local network. As soon as you drop off Wi-Fi and onto your cell network, you're going to lose access, because all the stuff on your local network is running on private IP addresses, and your router is going to block access from that public internet. The same thing applies to voice control. If you ask Alexa to turn on the lights, your voice has to go out to AWS to get parsed, and AWS has to be able to talk to your devices. If you're running everything locally, that's not going to work. So there is one simple solution. There's a thing called Home Assistant Cloud. It's a plugin from a company called Nabu-Casa. It costs $6 a month, and it establishes a bridge between your Home Assistant and the internet that lets you configure voice control. Nabu-Casa is run by the same people that develop Home Assistant, and the revenue they get from this plugin helps fund Home Assistant development and keep it open source. That plugin also solves the remote access issue by creating a secure tunnel to your Home Assistant interface that you can connect to from your phone and access your dashboard remotely. It can even proxy webhook calls to your instance if you want to. Now, you don't have to pay for this. You can build your own remote access and voice control solution as well. It requires a little bit of technical knowledge and a little bit of elbow grease. First, you're going to need either a static public IP address for Home Assistant, or you'll need to set up port forwarding on your router. And there's tons of guides out there that show you how to do that. If you don't have a static IP address, you're also going to need a dynamic DNS service. And the easiest way to do that is with the official Duck DNS integration for Home Assistant. It includes a TLS certificate from Let's Encrypt, so you can securely access your instance remotely. Rolling your own voice control is a little more complex because you'll need to create a custom Alexa skill to translate your voice commands into those Home Assistant commands. Guides exist for this, and if you have a big deal, it's not a big deal if you're already comfortable in this ecosystem. But I'm happy to pay the $6 a month to get it for free, or free in terms of time. So there's a lot going on here. And if you really lean into this local control concept, you may end up using a lot of these different services for different things. So where do all those things live? So this is my setup. I have one Raspberry Pi that's fully dedicated to Home Assistant OS, and another Raspberry Pi with an external hard drive that runs everything else like Grafana, Influx, and Mosquito as Docker containers. The external hard drive gives me plenty of space for all their logging information, and I won't have to worry about wearing out an SD card. And I have the flexibility of running other stuff like Python scripts or other services on that second Pi. If you're Docker savvy though, and you don't have two Pis laying around, you can put everything on a single Pi and run it in container mode. All those services can easily run together. Or the super simple thing is download a virtual machine onto your desktop and just add Grafana, Influx, and Mosquito all as Home Assistant add-ons. Now behind the scenes, those are still being run as Docker containers, just that Home Assistant is managing them for you. All right, so before I wrap up, I want to very quickly show off some of the devices and integrations that I'm most pleased with from my own home. In the end, I'll give you a link to these slides that has more information on these products. So one of the first switches that I put in was this combo light and fan switch from a company called iNovelli, and their stuff is awesome. They're out of stock on a lot of things right now because there's a shortage, but if they get back in stock, they just have top-notch stuff. This is in my office, and those LED light bars are fully configurable. So I have an automation that turns them red if my garage door has been open for more than an hour. So if I'm in the office and the kids leave it open, I can get a visual indicator that maybe I want to go close it. I like these multi-button scene controllers too. This is in our foyer by our front door. That big fat button controls the overhead lights in that room. The small buttons trigger scenes and automations. So I have one I can press at night. It'll turn off all the downstairs lights and get ready for bedtime. Another button we press when we're leaving, it just turns off everything. And yes, these labels are very ugly. I haven't gotten around to finding better stickers yet, and my wife keeps reminding me of that, but one day. She got me this handheld scene controller for Christmas. The coffee cup is just there for a sense of scale. So we have this in our master bedroom. It's got 8 buttons on it, so we can control all the lights in the master bedroom. Fans, lights, the vanity, the closet, the bathroom, everything without getting out of bed, which I think is awesome. And speaking of fans, we have this old pedestal fan in our bedroom, and we lost the remote for it. And I wanted to be able to turn the fan on or off without getting out of bed. So I had this thing called a SwitchBot. It's this little rectangular box. I zip tied it to the fan, and when I press a button in Home Assistant, a little finger comes out and hits the button and turns the fan on or off. I think it's really kind of cool. Definitely a little bit of a MacGyver type job there. So I have 3 different motion sensors in my basement, each tracking the path to the laundry area. So I could have bought 3 off-the-shelf Z-Wave sensors, wouldn't replace the batteries every 6 months, but I already had a Raspberry Pi down there to monitor my salt level in the water softener. So I just bought a pack of infrared motion sensors for like $5 on Alibaba or whatever, and I wired them into that same Pi using Ethernet cables. So I spliced the cable and wired it up and used the wires in the Ethernet cable to wire the sensors to the Pi. So the beauty of a locally controlled smart home is that you can mix and match off-the-shelf stuff with Frankenstein DIY hack jobs like this as much as you want to. Lastly, this is how I track whether or not my clothing dryer is on. So my washer is tracked with that Z-Wave power plug, but dryers use a different type of power plug. The same approach won't work. So I found this thing on GitHub. It uses a thing called a split core current transformer. This little thing just clamps around a wire inside the dryer, and it senses when it's drawing current. And I have a little ESP8266 microcontroller, like an Arduino, that monitors that device and puts out a thing on MQTT every 10 seconds or so. So this was my COVID hobby. I didn't mind learning about soldering and wiring and Python and all that other crap. None of it's required, right? You can build a very useful automation without ever touching a Raspberry Pi. But if you start with that local system, right, you have all the ability to implement your own solutions as the need arises. So I've thrown a ton of stuff at you, and there's no way you're going to remember all of it. So I put these slides along with detailed notes about the tutorials that I followed, the products that I use, etc. It's all on my GitHub, and you can get to it as a shortcut link there from Bitly. And the four main things I want to leave you with are that local control is really easy and secure with Home Assistant, and you can still have voice control and remote access to your devices. You can run it on a Raspberry Pi or in a desktop in a VM. You can add smarts to your existing appliances with flick.io buttons, that SwitchBot button pusher, and Z-Wave power plugs. And I'm a really big fan of my DIY laundry notifications. It really helps. And you can use InfluxDB and Grafana to track data over time in graphs and charts. You could track energy usage, your water usage, stock prices, whatever you want to track. And if you have any questions or comments or effusive praise or whatever else, you can get me on Twitter at Petry-Johnson. And I think I have maybe 3 or so minutes to answer questions here. So thank you for your time. Hope that was useful. Question. Thank you. Do any of those Z-Wave devices remember their state for power outages? I have a slide on that I cut for time. The answer is yes. For most of them, you can configure what state it should be in when the power comes back on. You can configure LED colors, the delays. You can turn off that delay for the scenes. I mean, most of the good ones have tons of built-in configuration. Yeah. Say that again, I'm sorry? Oh, for doing announcements over smart speakers? So I think in the March or April release of Home Assistant, they added a whole bunch of media stuff where you can do that. I don't have anything running yet, but there's a whole bunch of, there's Sonos integrations, there's a bunch of stuff. So they made media like a huge focus in one of the most recent releases. If I sell the home, how much of this stays? That's a great question. I don't know. I have so much stuff going that I don't know that I want to sell the house. It's like this is so molded around me. Nothing's permanent. The switches can come out. It's a matter of money. I mean, I probably have, I don't know, $800 in switches. So is that worth 8 hours pulling them all back out? Probably. But nothing is permanent. I could take it all down if I wanted to. Yes? How compatible is Home Assistant with HomeKit? I don't know that exact answer, but I'm sure it's decently compatible. I know, like, for instance, my Hubitat device, I can interface with that into Home Assistant. So there is likely an integration, but I don't know much about HomeKit just because it's Apple. But the community they have forums that are super active on Reddit. I mean, you could probably find an answer really easily. Do you have any DR scenarios? Do I have any disaster recovery scenarios? And also, how much of your configuration is automated? How much of the configuration is automated? Like how much of the house, basically, or what? What do you mean? Say you've lost a hard drive. So Home Assistant has snapshot backups. I back up the Pi occasionally, so I do throw it to my external hard drive. So in terms of like if I had to reconfigure it all, the Z-Wave network is stored on that little device, so I can just pull it out into a new Pi, and I back up once a month or so before I do the major upgrade. And I have random Pis running Python scripts that are all in the various stages of GitHub and elsewhere, so It would require a little bit of effort. I could do better if I wanted to do better, but time. Good question. Yes?
It sounded like you held back from hooking up a smart front door lock or a garage door opener. Is there any configuration in Home Assistant to maybe restrict those devices to like a MAC address or an IP address?
So I held back on installing like a smart doorbell or garage door. So could I install like a Wi-Fi device and restrict it from what it can reach out to? Is that your question? I don't know if it's in Home Assistant. I could do that on my network for sure. Like my firewall could block that. So you can do that. You can. I run a Pi-hole as well. Do you know what a Pi-hole is? So that blocks a lot of my outbound stuff. So yeah, there's things you can do. It's nothing built into Home Assistant specifically, but there's lots of options for it. I've been eyeballing Z-Wave door locks. I just haven't pulled the trigger on one yet. All right, I am being cut off, so they're playing the music and yanking me off. I will be on the Slack channel if you want to ask questions there, but thank you all for your time.